My name is Nasiullah Chaudhary. I go by CloudChamp on YouTube, and I work as a freelance DevOps engineer. So working as a freelance, I work on various DevOps tools. My most favorite is Kubernetes, obviously, and EKS is Kubernetes offering by Amazon. Okay. So yeah, this is my QR code. Anyone who wants to connect with me on LinkedIn, wants to check out my YouTube channel, can scan this code. All my links are there. So as I said, I work as a freelance DevOps engineer, DevOps consultant, anything you can say, because there's no particular role when you work as a freelancer. This is what we are going to talk about: Amazon EKS, Elastic Kubernetes Service. For those who don't know, EKS is used to create Kubernetes cluster on the cloud. It's all managed. If you don't do it managed, you will have to manage many things, set up your own certificates and stuff, which Amazon EKS lets you do it very easily. You just need to create a cluster, and you can start deploying your containerized applications on it. So this is a simple definition of what EKS actually is. Once you know what this is, and if you start using it in production, there are many, many things that you need to look into before you actually deploy your applications there. So these are some of the things that we are going to discuss. You might already know all of this, but there are a few things that I want to explain, or what things you should be doing when using all these particular concepts. So we have infrastructure as code, also known as IAC. What practices should you be using when you create Kubernetes cluster, or probably anything in the cloud? Am I going too fast? Okay, that's... Okay, I'll try to be slow. I speak fast and generally, but yeah, the first point is infrastructure as code. We are going to see what things you should be doing when you implement infrastructure as code for Kubernetes. Second is security, what things you should be looking at whenever you want to deploy your applications, because security is at paramount. If you follow DevOps, you might have heard about DevSecOps, which is a new term, and companies are very fond of it. They add it in all job descriptions, even though it's not an actual term. We already use security in all of our things. So DevSecOps is very similar to what DevOps already is. And we're going to see how you can secure your Kubernetes clusters. What are different stages or places you can secure your stuff. Next is scalability and high availability. If you have been following IPL these days, IPL is deployed on Kubernetes. Same for ChatGPT. They have, I guess, 5,000 nodes running to run OpenAI right now. So scalability and high availability is very, very important. And if you have, I'm curious, for people who have used Kubernetes in production, what is the most number of nodes you have used so far? Any number? Yeah. Oh, okay. More than 23? 800. I have seen projects where they're using more than 1,000 nodes, which is very, very difficult to handle. Although Kubernetes is self-managed, it can do things automatically, but still there are a few things that you need to look into whenever you want to scale or make sure that your applications are highly available. Next, we have observability, which includes monitoring, logging, and tracing. Very, very common, very, very important to make sure that your application is running as you want, to make sure there's no problem. We are going to look into what things you should be doing whenever you consider observing your applications on Kubernetes. And then there's cluster version upgrade. There could be more points as well, like cost optimization and other stuff. But I don't want to add all of that. So here are 6 things that we are going to be covering in today's session. So first is infrastructure as code. What are popular IAC tools you have used? Terraform. Yeah. CloudFormation. Even though this is AWS Community Day, I still promote Terraform because I like Terraform more compared to CloudFormation. And this is a snippet here on how you can create a Kubernetes cluster using Terraform modules. Terraform modules let you use code that is already there, published by someone. So you can use modules and then just refer stuff, like how many nodes you want, what should be the VPC and all the stuff, right? And this should be the best practice whenever you create clusters, not just clusters, anything you do in the cloud should be through infrastructure as code. So you should not be clicking on buttons. Rather, you should be creating code either in CloudFormation, either in Terraform, either in Pulumi, or any language you want using SDKs. So create cluster declaratively rather than you create it manually by clicking on buttons, because these are all different benefits that you get. Consistency. Let's say you have different environments, staging, pod, pre-pod, and other stuff. You can use the same code to deploy things in your staging, in your development, in your prod, in your pre-pod. Everything would be the same. You can just change values in variables to deploy the same things in different environments. Next is version control. If you create your infrastructure using code, you can push it on GitHub or GitLab or Bitbucket. So you can version control stuff, right? If there's any problem, you can revert back as well. Same for prevent drift. There's no, let's say you have 3 different environments. If you change things in production, you will have to change things in staging as well, in development as well, which is very common if you do it manually. But when you do it with infrastructure as code, there's no problem with that. Same for collaboration. Anyone in the team can collaborate on the same code. Automation, obviously when you use IC, you can implement CI/CD in it. And there's a great YouTube video that I created. Not trying to self-promote, but it's actually a good video which you can watch. Integrating Terraform with GitLab to automatically deploy stuff. Next is security. Security, very, very, very important whenever you deploy stuff on Kubernetes. So as we are using EKS here, which is Amazon Managed Kubernetes Service, you can secure your applications or workloads using AWS as well as Kubernetes specific tools. So anyone here who is Kubernetes certified? Okay, great. So there are a few terms that you might not be aware about if you're not certified. Maybe I'm not judging here, but still. So this is different layers where you can integrate security. You can start from pod, which is the smallest entity in the Kubernetes cluster. Then you could also implement security on the node, on subnet, on VPC, region, or on AWS account itself. In AWS, you have different tools like IAM, KMS, then Secrets Manager, or different tools that you can use to implement security in your workloads. Let's look at that. So first thing is securing your cluster itself. Using IAM and different tools like security groups, NACLs, you can manage who can actually control your cluster, which is the first step. Network security. Second is credential security. You should not be hard-coding your stuff, which is very common, but you can use tools like SSM, parameter store, or Secrets Manager to put your database keys, access keys, anything, rather than putting it inside your declarative or manifest files. Next is in-cluster security. You can use tools like Calico. There are also other open source tools that you can use, but I think Calico is good for network policies where you can define what you can do, what you cannot do. Another tool is Open Policy Agent or OPA as well. A great tool to check out whenever you want to restrict what pods can do, can it access a file system inside a cluster or not. So this is in-cluster security, and then later on, you can use different tools like KMS, IAM, Secrets Manager on the AWS side to enhance more security using AWS tool. So this is security, but there are also many things you can add. These are something that you should be checking whenever you deploy your applications on security part. Next is scalability. So as I said, there are many companies that are actually using Kubernetes to deploy their stuff. They handle security, they handle scalability using these tools, but these are something related to Kubernetes. So you can do scaling on 2 levels, either pods or cluster. By pods, I mean you can create pods and delete pods. And by cluster auto-scaling, I mean creating nodes and deleting nodes. So for pods, you have HPA or horizontal pod autoscaler, where you can define that on a particular limit, I should be adding more nodes, more pods, right? Similar to HPA, on HPA, there's a new tool that is built upon, which is KEDA, stands for Kubernetes-based event-driven autoscaling. I don't know if you can see this image here, but you can see KEDA is integrated here to autoscale pods based on metrics in AWS. So let's say you have an application which is creating SQS queues or storing data on RDS. You can put that as a metric to autoscale pods inside your cluster. So if you're using EKS, you can also use KEDA to scale your applications based on metrics inside AWS. There's actually a blog by Abhishek Gupta, AWS team. So he has mentioned how you can use DynamoDB streams to automatically add more pods inside your cluster. So let's say you have an e-commerce application. Based on that, you might be creating SQS queues that will let you add more pods based on the traffic coming in. So this you can use something if you have metrics based inside AWS using SQS queues or CloudWatch metrics or Kinesis streams as well. On the other hand, for cluster autoscaling, which is adding nodes based on the traffic coming in, you can use two things. AWS supports two things, cluster autoscaler, and then there's another open source tool named as Carpenter. So these tools you can use to autoscale cluster, which means adding new nodes whenever the traffic is coming in. And AWS has a good blog explaining how you can use Carpenter and also cluster autoscaler. All of these are referenced from the AWS documentation, and I have a slide where there are links as well. So you can check it out whenever you want to. So after scalability, you also need to check availability. You need to make sure that no matter what, my application should be running. Customers should be able to see my application running. So very basic step that I haven't mentioned here is whenever you deploy an application, make sure you deploy it as a deployment, not individual pods. Because if you see here, when you deploy as a deployment, you mentioned I want to have 5 replicas, 6 replicas, 10 replicas, right? And Kubernetes is self-managed. It is self-healing tool. So whenever there's less replicas, it will try to make sure that the count is what you have mentioned inside your manifest files. But other things that you can use or utilize to make sure your applications are running as you want is probes. In Kubernetes, there are 2 kinds of probes, liveness probes and readiness probes. These probes you can use to add a health check for your pods. Let's say you have a pod which is running on port 80 and it is showing something. So you need to add a probe saying that this application should be running on port 80 and it should show me this. If it is not showing, don't put the traffic on that pod. So this you could add so that every time your application is not healthy, it will delete it and create a new pod for you. So this you can do using probes, and I highly recommend you adding that if you don't want your customers to see 502 or 404 errors, right? Next is distributing your pod replicas across various nodes. So pod is smallest unit in Kubernetes, and it is very common for a pod to go down, or it is very common for a pod to face issues. So make sure you always deploy your pods on different nodes, and this you can do by mentioning it inside your manifest files, specifying what node you want to use, or you can use affinity rules as well. So this is something you can do to make sure your pods are highly available. Next is deploy worker nodes. So when you create a Kubernetes cluster using EKS, after you create a cluster, you need to create a node group. And inside a node group, you need to define what subnets to use. So rather than selecting just 1 or 2 subnets, you can mention 4 or 5 so that Kubernetes EKS starts deploying application in different AZs. Even if one of them is down, you can still have your application running, right? Next is rolling updates. When you deploy an application and you want to update it from version 1 to version 2 or version 3, there are different deployment strategies. One of them is rolling update. Using rolling update, it does not delete all the versions of the pod. Automatically, it will first upgrade one pod. If it works fine, then it goes with the next pod, and so on. This means there's no downtime, and you don't have anything bad happening. So you can use rolling updates and rollbacks whenever you update your application. There are also other options as well, but this is the one that Kubernetes suggests you whenever you want to upgrade your pods or change versions. So this is for high availability. Next is GitOps. Very, very common, very important to know. People are not deploying applications directly. They are using GitOps to do that. So what is GitOps? GitOps stands for Git and Ops, where you store your manifest files inside a repository, a Git repository. Whenever you make a change, let's say you have a manifest file saying I want to have 10 replicas running all the time, right? But now there's another customer that has joined in, so instead of 10, you want 15 now. If you do it manually, you will be changing the manifest file, running the kubectl apply command, and then you will check if everything is working or not. Using GitOps, you just need to push the change, like changing from replicas 10 to 15, and just push it. When you push it, any GitOps operator, like Argo CD here, will check what change you made, and according to that change, it will make sure that the desired state is as the user wants inside the Git, right? There used to be another tool, Flux CD. Anyone used Flux CD before? Okay, yeah. So Flux CD was another great tool that I used to use, but Weave networks or Weave works have stopped it. So there's Argo CD right now by Red Hat, but it's open source. So you can check out Argo CD. It's very cool. You can push your manifest files on GitHub and connect your cluster with the operator to see how it automatically changes or syncs. Depends on what you have inside your Git repository. So this was GitOps, but whenever you have GitOps, so you have manifest code, which is responsible to deploy workloads on Kubernetes. You also have application code, which could be Python or whatever your application is. Make sure your application code and your manifest codes are separated from each other. Why? Let's say you have application code where you are setting up a CI/CD, which automatically creates a build, and then have a new version every time you push it, right? Everybody is okay with CI/CD concepts, right? Knows what CI/CD is, right? So in CI/CD, whenever you make a change in the code, it creates a build, which could be Docker file, Docker image, or maybe a Maven jar file, var file, anything, right? Every time you push something, a build will be created. So let's say you change your manifest files from replicas 2 to 5. You don't want the build to be created all the time, right? This is why you should be separating your manifest files with the application code so that it does not automatically builds all the time even though you don't want to build it. So this is first practice I would suggest, separating your manifest files with your code repositories. Second is implement syntax correctness or all the different tests whenever you have GitOps. So you can add syntax correctness, security best practices, and also conflict checks to make sure that whatever you're creating is actually good. And always check changes in staging before you apply in production. This I can tell you with experiences because I have done very bad things to my customers, so I don't want you to do that. So always test changes in staging environments before you move into production. Next is observability, very, very, very important. To make sure how your clusters are working, how your applications are working inside it, you have to always check. And this could be different for everyone. A company might have a customer, a company might be a gaming application, or a company might be an e-commerce. For them, observability will be different for all different companies, right? So what are 3 important things? What should you monitor? So there are 3 things: metrics, logging, and tracing. So metrics you can use. Metrics are like CPU metrics or memory usage. Logging will tell you what is happening with your cluster or what is happening with your container. Next is tracing, who is doing what on your cluster. So these are different tools that you can use. Prometheus, a very popular open source tool that you can use to monitor your cluster. EKS now has Prometheus inside it. So let's say you don't know how to install it. You can just go ahead with using manage Prometheus by EKS. Or you also have add-ons in EKS. You know add-ons in EKS? EKS add-ons. Let's say you are working with Prometheus, you can add Prometheus as an add-on. If you're working with Splunk, AWS has a wide variety of different customers that you can use. So Prometheus is one of the tools that I use regularly. It's also industry standard. Everyone, I guess, is using Prometheus, unless there's an enterprise customer who might be using Sync or Datadog or any other thing. But the thing is same. You have to check what metrics are important for you. Then you can implement logging, tracing, and these are all different benefits on why you should observe your applications on Kubernetes for faster troubleshooting, performance insights, forensic analysis, and all those stuff. So what things should you take care whenever you implement observability? So there are 2 best practices here for logging and for monitoring. Whenever you set up, like you should be obviously setting up logging, and when you set up logging, you should set retention period on how long do you want to keep this logging data. Maybe a application will be very critical. You might need to store this data for a 10 years time period, or maybe 1 year time period, or maybe 10 days. It's up to you. So enable logging and set retention period. Whenever you have logs for short term, you can keep it in CloudWatch. But if it is for long term, let's say 10 years or 15 years, you can use S3 storage classes. S3 has different storage classes like Glacier, Standard. So if you want to save cost, long-term log should be in S3, short-term log should be in CloudWatch. Set retention period that it should be deleted after 10 days or 15 days. For monitoring, this is one of the best practice. I would recommend you monitor only what you need and collect what matters, or monitor what matters and collect only what you need. Because when you enable monitoring, you will obviously be setting up alerts maybe on Slack, Pager, Jira, right? So you don't want all small notification to be coming up as well. So only monitor and set alerts for what actually is important for you. And this is best practice whenever you set up monitoring, either using Prometheus or any other tool. Next is version upgrade. Kubernetes releases their new version every 4 months, and they suggest you keeping at least last three versions of your clusters. If it is more than that, maybe it is most of your application will not work. And Kubernetes suggests you to upgrade your clusters to make use of new features that are coming in. And here is the Kubernetes release calendar, which has all the Amazon EKS new versions. There's a blog or a documentation online you can check out. This is just a screenshot from it. So it is always recommended to use the newest cluster, and you can always upgrade your existing clusters as well. There's an option on the UI where you can just change, and Kubernetes will upgrade it for you. If you're using other options like kubeadm and stuff, you will have to do it yourself. So yeah, keep your EKS clusters up to date and take advantage of benefits Kubernetes provides. So whenever you want to make use of new features, you need to upgrade Kubernetes. Then always test your workloads on staging before you upgrade your production clusters. And always use tools like Prometheus, Grafana to check everything is working fine, all your applications are up. And yeah, this is what last best practice I have. Lastly, there are many tools in the market that you can use to make sure you are following best practices. One of them is Harden EKS. This is by AWS itself. And it's a tool that you can install using Python in your cluster. And it will provide you with insights on what you should be doing to make sure your cluster is following different best practices. So there's Harden EKS, but there's also Caverno or other open source tools that you can use. This is by AWS. So yeah, we are in AWS Community Day, Harden EKS. So this is a GIF to help you explain. I'm not sure if you can see it or not, but when you run Harden EKS command, it gives you all the different best practices that you can implement to make sure your cluster is secured. And AWS has a best practices guide that you can check for observability, for cost reduction, and everything else to go more in depth on what we have learned today. So I have references added for everything here. You can check it out. If you want me to share you the PPT, you can let me know, or I guess people will share it with you once the meeting ends. But these are the links that you can use. The first link is for the best practice guide, which includes all the guides for reliability, cost savings, and other things. Then there's a blog on Carpenter, which was cluster autoscaler for AWS. There's a blog of Kida, which shows how you can use RDS data to autoscale your pods. Then there's Harden EKS, a blog on how you can use it and what Harden EKS actually is. And lastly, if you are interested about GitOps, how GitOps works, how you can use Argo CD to implement GitOps, you can check out this workshop by EKS. They have the commands and also a project that you can try out. So yeah, this was my demo. I know it's very fast. We still have 6 minutes left. But this is all I have for today. I hope you have learned something today. Thank you.